Hello everyone. So today we are going to solve question number 1615, Maximal Network Rank. So let's first read what the problem statement states. So there is an infrastructure of n cities with some number of roads connecting these cities. Each road at I is equal to AI, BI indicates that there is a bidirectional road between cities AI and BI. The network rank of two different cities, so this is to be noticed, two different cities is defined as the total number of directly connected roads to either city. If a road is directly connected to both the cities, it is only counted once. So also the maximal network rank, this is what we need to find, of the infrastructure is the maximum network rank of all pairs of different cities. Given the integer "n" and the array roads, return the maximum network rank of entire infrastructure. So from the entire infrastructure, we need to find the maximum network rank. Let's see our first example. Here n is equal to 4, so that means we will have cities 0, 1, 2 and 3. And the connections between these cities is given as 0 is connected to 1, so this is the network. 0 is also connected to 3, so this is 0 to 3. Also 1 is connected to 2 and 1 is connected to 3. So what we need to find is a pair of cities taking which the maximum we get. So for example, if we take cities 0 and 3 here, so how many roads are connected to 0? 1, 2, only 2 roads are connected to 0. And how many roads are connected to 3? 1, 2. So only 2 roads are connected to 3, but we see that this road is repeating, so we need to take it only once. So our result will be 2 plus 2 minus 1. So we can observe one thing, that the maximum we are taking is nothing but the degree of connected edges to a node. So what we need to find is the degree of each node, and we also need to check if there is a connection between two cities or not. Let's look to example 2. So here first let's see this. So our example, in our first example, if we take 0 and 3, the result will be 3, and if we take 0 and 1, then only we'll get 4, because two nodes are connected to 0 and there are three nodes, this and this connected to 1, minus the common node which is this. So this will give us the resultant of 4. In example 2, we can see this is the graph given, and by taking the nodes 1 and 2, we get the maximum. So let's first try to write the degrees of each node. For 0 we have degrees 1 and 2. For node 1 we have degrees 1, 2, 3 only. For node 2 also we have degree 3, this. For node 3 we also have degree 3, and for node 4 we have only 1. So we need to find the pairs with maximum degree. So we need to take this and this. But there is one thing, that it's possible that some roads might be connected or they might not be connected. So thus we need to check all the pairs of cities, and then only we can decide which is the maximum one. By looking at example 3, we can see that 0 is connected to 1, 1 is connected to 2, 2 is connected to 3, and 2 is also connected to 4, 5 is connected to 6, 5 is also connected to 7. So we see that it's not necessary that all the cities are interconnected somehow. We can also have two separate graphs. So we have one part as this separately, another part is this. And in this example only we notice that all the cities do not have to be connected. And looking at the constraints, it's 10 square. So we can go up to big of n square, which will be 10 to the power 4. We can go and cube also. But let's see how to solve this. So what is required to solve this problem is we need the degree of each and every node and some method to determine if there is a edge between two nodes. So how can we achieve this? Now let's move to the code. So I've previously coded the solution to save time. So for this solution we will use a set of adjacency list. We will try to make an adjacency list, but instead of vector we will use set here. So we not normally make adjacency lists with vectors, but why I'm using set here? So the reason for that is we need to check if there is a connection between two edges, and if I'm not using set, then I need to traverse the whole vector to find if there is an edge between two edges or not. So this is clear that we need to use set as a form of adjacency list. Now we have made the set of adjacency list. Then we need to insert all the roads. So we will traverse the roads, given roads, which are I and j, suppose. So at each road we will make the adjacent of 0th to the first, and similarly as the graph is bidirectional, so we will also connect from x at 1 to x at 0. So from the adjacency list, next we are using a visited array. We required a visited array when I was using vector, but it's not required now. So I need to remove this. We will keep a variable result to check if to, to get the maximum of the all values. Now we simply need to traverse for all the pairs, possible pairs, and for doing that we will simply use two for loops, nested for loops. Outer loop will run from 0 to n minus 1, and the inner loop will run from I plus 1 to less than n. And inside the loop what we need to find is, because the as we have made the adjacency list, so let's see how we make adjacency list first, then it will be more clear to you. So let's take example 2 only. So first we get the 0. In the adjacency list we have a array of sets. So we have set 0, set 1, set 2 till set n minus 1. So this is what we have written there. We have made set integer, and we have made an array of size n. So this is how it's internally represented. We have set 1, set 2 and all, and the array of sets is what we have made. Initially it's empty, so when we first see this 0 comma 1, we will go to the index 0 of this adjacency array. So its 0 index is empty, initially empty. Then we will insert 1 at that place. So here 1 will be inserted. Probably leave out the space for the remaining things. 1, 2, 3, and 4. So at 0 index, 1 index, 2 index, 3 index, 4 index. We also need to add 0 to the first place. So we will add 0 here. Next, when we see this block, we will add 3 to 0 index. So here it will be added. And we'll also add 0 to the third index. Similarly, we'll fill the rest of the values. So next of 1 will be 2, and 2's next will be 1. Then 1 place we will add 3, and 3 will also add 1. Then 2 to 4, 2 will add 4. In 4 also we'll need 2. So we can see that at 0 we have only two numbers, and at 1 we have 3 numbers, and at 2 I think I made something. 2 2 to 3. Oh, so here 3 will be also there. So it's 3, and 3 to 2. So this 3 and 4 is 1 degree. So by the size of the set we'll get the degree of each number. So we understand now that the degree of each number is the size of the each set. So for current we'll get the set of each number. So we have now the two edges in all the pairs of edges, because I and j will loop, and at each traversal we get different sets of numbers I and j. We will take the size of I and the size of j, and then we need to check if there is an edge between I and j or not. So how can we check it? We will go to the set of I, or we can go to the set of j also, and we will check if j is present in the set I or not. If it's present, that means there's an edge, and if there is an edge, we will have counted this edge twice, because it will also be an edge in I and also be an edge in j. So we need to subtract 1 from the current, and then we need to take the maximum of the rest, and this will happen for all the I and j pairs, and eventually we will get our result. So let's submit this. And I've already solved it a few minutes back. So you can see this was not a very tough problem. It's just the basic implementation of the edges of set and the simple loop traversal. And this was the 505th day of me consistently solving the LeetCode. Thank you. See you in the next video.